Today, we are going to understand pigeonhole principle. The basic pigeonhole principle says, if there are n plus 1 pigeons and n pigeonholes, which means the number of pigeons is 1 greater than the number of pigeonholes, then there is at least one pigeonhole with at least 2 pigeons in it, as demonstrated in this diagram below. There are 4 pigeons and only 3 pigeonholes. That's why there is at least one pigeonhole with at least 2 pigeons in it. Note that the statement doesn't say that each pigeonhole needs to have at least one pigeon in it. What it means is one or more pigeonhole can have 0 pigeons in it. For example, let's look at this situation. What this theorem means is that all of these women can like the same guy. There are pigeonholes with no pigeons in it. Okay? Now let's go to the proof of pigeonhole principle using proof by contradiction. By way of contradiction, suppose no box contains 2 or more pigeons. What this means is every box or every pigeonhole contains at most only 1 pigeon, right? And since there are n boxes, the total number of pigeons is 1 times n equals n. However, the number of pigeons in reality, in fact, should be n plus 1. There is a contradiction. Therefore, there is at least one box that contains 2 or more pigeons. Okay, now let's look at the general pigeonhole principle. In the general pigeonhole principle, what changed is the number of pigeons. So it says, if there are n pigeons and k pigeonholes, so n pigeons and k pigeonholes, then there is at least one. So at least one. This is the same as the basic one. Look, at least one pigeonhole, at least one pigeonhole with at least the ceiling of n divided by k pigeons in it. So don't worry about this ceiling symbol. I'm going to explain why we're taking the ceiling and not the floor later. So this is the theorem. Again, it does not say that the pigeonhole needs to have at least one pigeon in it. It doesn't say each pigeonhole needs to have at least one pigeonhole in it. So there can be pigeonhole with 0 pigeons in it. All right? The proof of general pigeonhole principle is similar to the one above. I'll just read it out loud. So again, by way of contradiction, suppose there is no pigeonhole with n divided by k pigeons in it. So that means all pigeonholes have at most n divided by k minus 1 pigeons in it. So since there are k pigeonholes, the total number of pigeons is less than n divided by k times k, which is n. And this is not the reality, because the number of pigeon should be n, not less than n. Not less than n, as shown here. It should be n. So there is a contradiction. Therefore, there is at least one box that contains the ceiling of n divided by k or more pigeons. Now, I want you to look closely at the relationship between the general pigeonhole principle and the basic one. So we can plug in n plus 1 to the numerator and n to the denominator into the general pigeonhole principle, and we'll get this. N plus 1 divided by n, and we take the ceiling of it, and it will be 2. So we can conclude that they're actually the same thing. So this case, the basic case, is just an application of the general pigeonhole principle, right? So now, as I promised, I'm going to talk about why we're using the ceiling. So we are interested in knowing at least how many pigeons there are in the set pigeonhole, right? We're talking about at least. And if the answer that came out from doing n divided by k is, for example, 3.77, should we take 3 as the answer, or should we take 4 as the answer? The fact that there are at least 3.77 pigeons means at least more than 3 pigeons. So, what is at least more than 3 pigeons? That means 3 plus 1, because the next integer after 3 is 4. That's why we can reasonably conclude that there are at least 4 pigeons if the calculation we got was 3.77. So this is the reason why we are going to use the ceiling instead of the floor. I hope it was clear, and thank you for watching the video.